In this video, we're looking at types of discontinuities. So quick refresher, we learned what continuous means. So continuous has three parts of definition. Our function value exists, our limit exists, and those two things are actually equal to each other. When this function is, these rules are not satisfied, we call it discontinuous. So we just put a little dis in front of continuous. So the first type of discontinuity is known as a removable discontinuity. This happens when the function value does not exist, or the function value exists, but the whole of the two do not agree. This is going to be seen as a hole in the graph. So it could be, this could be a removable discontinuity. Sometimes you have a function value still, but it doesn't agree with where that hole is. So when you just have this single kind of hole in your graph, it's a removable discontinuity. The noticeable thing for removable discontinuities is the limit exists. All right, so you can see the limit would be this value or that value. So when the limit exists, but it's still not continuous, that's a removable discontinuity. The second type of discontinuity is a jump discontinuity. So the left and right limits do not agree. All right. This means the limit doesn't exist, so it can't be continuous, because part of the continuous definition is the limit existing. So jump discontinuities, we already talked about, that's when the limit doesn't exist. That will be a type of discontinuity. And the last one we'll talk about is infinite discontinuities. So if you have an asymptote, again, the limit doesn't exist at an asymptote, so that means the function can't be continuous. So this is a type of AP question, is classifying a discontinuity. So we know this function is not continuous at 2 because I can't plug in 2. If I try to plug in 2 minus 2 equals 0. So we know it's not continuous because the function value doesn't exist. All right. But now we see, does the limit exist? Because the limit exists, then it's a hole. If the limit doesn't exist, then it's one of the other two. So let's see if this limit does exist. So if I try to find the limit as x approaches 2, of x squared minus 4 over x minus 2. Again, first thing you always try to do with a limit is plug in the number. If I plug in 2, I get 0 divided by 0, which is my hint that I can keep simplifying this. And I can, because I can factor the top, because it's the difference of squares. I can cancel out the x minus 2's. And then, because now I just have a polynomial left and I cancel out factors, I just plug in my number and I get 4. So the limit exists even though the function value doesn't, and this tells you this is a removable discontinuity, right? Or a hole is kind of how we refer to it more often, right? But the kind of fancy name, removable discontinuity. All right, your limit exists, but you can't plug in the value. All right, what about this example? All right, if I try to plug in 3 right away, I get 3 minus 3 is 0. So my function value does not exist. But what about the limit? Let's look at the limit. X approaches 3, x squared minus 4 over x minus 3. If I were to try to plug in 3, I'm going to get 9 minus 4 is 5 over 0. If you don't get 0 over 0, that means nothing's going to cancel. If nothing cancels, then you can never plug in this number, which means this limit does not exist. All right, so the function value doesn't exist and the limit does exist. So it's not a removable discontinuity because the limit doesn't exist either. So which type is it going to be? It's going to be infinite. And how do we know that? We know that because if we're working with rationals, these fractions, and the bottom does not cancel out, you get an asymptote. All right, so with rationals, you pretty much have asymptotes or holes. It's not a hole, so it's an asymptote. Right? Jump continuities, discontinuities are really going to happen when you have piecewise functions. All right, they're really rare. The other time you might have a jump continuity is when you have an absolute value. But with rationals, it's pretty much whole or infinite. All right, so here's the quick summary. There's 3 types of discontinuities. There's removable. I remember that happens when you can cancel out a factor in the rational. So if you cancel it out and you can find your limit, then you have a removable discontinuity. All right, jump happens when the two sides don't agree. That happens a lot with absolute values. And infinite happens at a vertical asymptote. So when you can't cancel out that factor and you still have 0 on the bottom for a rational, that's when you get an asymptote, and that's your infinite discontinuity.